Alright, so we got some trig and special right triangle practice day, a little bit of extra practice from last week. I know for some of you guys it may have been a little bit confusing with all the trigonometry and the unit circle and all of that. Give it time, give it practice, and I promise you it'll start to come together. Alright, now here's a good day for you to practice some trigonometry that you've done before. We have two things here. We have a reference angle in green, 50 degrees, and we have this 12 right here. Now, because the 12 is across from the right angle, I'm just going to say that that's my hypotenuse. I'm just going to label it right now, that's my hypotenuse, because it's across from that 90-degree angle, that right angle. However, I have two sides of this triangle that don't have anything. I have this side, and I have this side. So two sides, two legs of the triangle, if you will, that don't have anything. Let's just start labeling this. Because my reference angle is in green, I know that across from my reference angle is O. That would be opposite. Anything opposite of your reference angle, that's O. Again, I don't know what that is. We can leave it as O for a little bit. And then if I have opposite and I have hypotenuse already, I just know that this is A. This is my adjacent. Again, it does actually touch the reference angle. We can call that adjacent. The only side that I'm given is my hypotenuse. The other two sides, I don't know what they are yet. That's what the whole point of using trigonometry is, to figure out what those other side lengths are. Alright, so let's start with this. Let's start with sine. I'm going to go ahead and set up all three of these, and then we can figure out which one's easiest to solve. We know that sine is so, right? So katoa. Sine is so. S equals O over H, opposite over hypotenuse. So sine of 50, everything that we do is in our reference angle, in respect to our reference angle. Sine of 50 is equal to O over H. I do not know my opposite. I don't know what O is. But I do know what H is, because H is the one value that they gave us, which is 12. Sine of 50 is equal to O over 12. Now, maybe O is not the best one to use because O looks a lot like 0. So let's just call this X. X over 12. But again, it's opposite. We're just, O looks too much like 0. It's not worth using. Alright, so how do we solve this? Well, if I want to get rid of this fraction, what I'm going to have to do is multiply both sides by 12, and these will cancel. On this side I'm left with X, and on this side I'm left with 12 sine 50. Okay, I don't know what this is yet. Sine of 50 is not something that I memorized, so let me resort to my calculator. 12 sine 50, if you pull out your calculator, which this one is here, alright, you can see I have some plugged in already. 12 sine 50, first thing, go to mode, make sure you are in degrees. If you are in radians, it's going to give you the wrong answer. Make sure you are in degrees, because we are talking about a triangle. We're talking about degrees of a triangle, so we need to be in degrees. There are times where we will use radians. In the unit circle, it's actually really nice to use radians, but we want to be in degrees right now. Alright, so we're in degrees, 12 sine 50. 9.19. 9.19. That means that, since I plugged these in, X is equal to 9.19. Good, I can fill that in now. So that helped me find one side of the triangle. Let me erase this X, and I'll use 9.19. So I have 12 for my hypotenuse. I have 9.19 for my opposite. Cosine, let's see cosine. Cosine is ka, right? So ka, toa. Cosine is ka. A over h. A over h. So let's set this up. Cosine, and again, everything is in respect to our reference angle, which is 50. So cosine of 50 is equal to A over h. A I don't know, because A is the adjacent. I don't know that one. So I'll put A over h I do know, which is 12. And now I can solve. Because this triangle is a 90 right, because this triangle is a right triangle, we can use cosine, tangent, sine, any of those to get all three sides. Now, you'll see with tangent, but we don't know what A is here. So we still have this A left that we have to solve for. Once we figure that out, we can always plug it back in and give us a whole number, a decimal for what the actual cosine of 50 is. But right now I'm just trying to find what that A is. So how do I do that? Well, I take this, I multiply this side by 12 to cancel that out, but I have to multiply this side by 12 too. So what do I get? 12 cosine of 50 is equal to A. 12 cosine of 50 is equal to A. Hopefully you're, because I'm writing on this, I'm still not sure about the size to write with and all of that. So it looks a little messy, so I apologize, but hopefully yours is a little bit cleaner. 12 cosine of 50 is equal to A. Here we had 12 sine of 50. Here we have 12 cosine 50. Those are two different values, so we have to be careful which one we're using. We are trying to find cosine of 50, so that's what we will use. Go back to your calculator. 12 cosine 50. What do I get? 7.71. 7.71. A is equal to 7.71. All right, tangent. Now, we don't technically have to do tangent because we already found the three sides. We have this side being 12, we have this side being 7.71, and then the bottom side being 9.19. So we all have all three sides. We don't really have to do tangent, but it's a good check to make sure that you did it right. So let's just do it. All right, so tangent, we know tangent is TOA, or opposite over adjacent. So tangent of 50 is equal to the opposite, which again, opposite being directly across, that's 9.19, over adjacent, which is the yellow one, 7.71. All right. Tangent 50 is equal to 9.19 is divided by 7.71. If this is true, then we did it correct. If this is false, if this gives us two different values, we need to go back and check. So tangent 50, let's go to my calculator. Make sure I'm in degrees, mode, degrees, good. Tangent 50. So that's equal to 1.19. All right, tangent 50, we said was 1.19. Now, if I divide 9.19 over 7.71, if I divide those two, it should equal 1.19. And that was 9.19, 7.71. 9.19 divided by 7.71, which is 1.9. It's very, very close, 1.19195, very close because we rounded. But because these two are equal, you can see them right above each other. Because those two are equal, I can say all of these are true. Okay, good. This was 1.19. Check. And I am good. I have all three sides. I have two of the three angles, but this angle is pretty easy to find, 40 degrees. So that's it. That's why we use trigonometry. I'll let you guys do this bottom one on your own. It's a 45, 45, 90 triangle, so maybe that's a good hint for you. Should be a little bit easier, but again, take your time. I know it's messy up here, but you guys will write it cleaner than that. Sine, cosine, tangent, you may have to divide, you may have to multiply, but again, you're just solving an equation here.